Hello everyone, welcome to the lecture series of Microprocessor with the subject code KCS 403, and this subject belongs to the branch CSC and the other sister related branches of your computer science, and maybe in the third year EC students will also study this subject. So the topic which we are going to discuss today belongs to chapter 5 unit 5, and the topic name is PPI, that is your programmable peripheral devices. And the IC used for this peripheral IC number specific IC is, we have this 8255 IC. So what basically is this programmable peripheral IC? So when we need to communicate with some external devices, one possibility is we can directly connect those devices to your 8085 or 8086, but that device should be compatible with the with your microprocessor. The another thing is we can interface that device with the help of this programmable peripheral interface IC, that is your 8255 PPI IC. It is also known as PPI IC. So the main features of this IC is, it is a programmable device. We can program the ports available on this IC as an input port or as a output port, right? So it has 24 IO programmable input pins, programmable pins, and we have these 24 IO ports are classified into port A, this is your port A, port B, and port C. Each port will have 8 pins, so the total 24 IO programmable pins we can have. Next, the next feature of this IC is this 8255 IC is TTL compatible, means whichever IC which is made up of your transistor logic, we can communicate with that IC with the help of this PPI IC. It has improved driving capability. This is the block diagram of 8255 IC. So in this block diagram, we can see that this is the internal data bus. This is the internal data bus, which is used to carry the data which we have to display at some output device, or we have to receive from any input device. So here you can see that we have this port A, port B, and this port B and port C, which is divided into two parts, port C upper and port C lower. So in this way, we have this port A, port B, and port C. These ports are of 8-bit, which is shown in the diagram. This port C is divided into two parts, port C upper and port C lower. Port C upper contains the bits from PC7 to PC4, and port C lower, it contains the bits from PC3 to PC0, right? And this port A and port C upper are combined to form a group A. So this group A contains port A and port C upper, 4 bits of port C upper, and your group B contains port B and port C lower, right? So to control this complete group A, to control this group A, we have the group A control, and to control this group B, we have the group B control, right? So group A control will initiate a control signal, and it will send to the components which are connected to group A, that is your port C upper and port A, and group B will generate a control signal which will control the working of group B, that is your port C lower and port B, right? So here we have data bus buffer, which will provide 8-bit data bus, that is your D7 to D0. Here we have read write logic control, which provides the value read bar, write bar, A1, A2, reset, and CS bar. So when the value of this CS bar is equal to 0, when here the value is 0, it will your IC will be enabled, else it will be in disabled mode. When the value of this read bar signal is 0, you can read some data from the output device, from the input device which is connected at an input port, right? For example, we have interfaced one keyboard. To read any key from that keyboard, we must put this value 0. Right bar, the right bar logic, it should be 0, so that we can display any data which is available on data line to some output device like monitor, or we can print any data. A1 and A0 are used to select the ports. And reset, when your reset pin is activated, means when the value of this reset is 1, it is active low signal, no bar signal is applied on this. So it is an active high signal. Whenever the value of this reset pin is 1, it states that the contents of control words will be reset, and second thing, all the ports will be initialized as a input port. So one thing that we should keep in mind, that whenever we switch on the device, we press reset so that all the garbage value is removed. So these ports will behave as a input port. So let us quickly read out the components which were present in the block diagram. So first one is your data bus buffer. It is a 8-bit bidirectional data bus. It is used to interface 8255 data bus with the system bus. Suppose you are interfacing this 8255 with 8085, right? So we know that 8085 also has 8 data lines, right? So out of these 8 data lines, 2 will be connected to the A1 and A2, and rest all we are going to connect that to chip select signal, so that we can enable the chip, right? So the internal data bus and the outer pins D0 to D7 are connected internally. The direction of the data transfer is decided by the read-write logic control signal. Next, read-write control logic. It is used to get the input signal from the control bus and the address buses. Control signals which are used under this block is your read bar and write bar. Address signals which are used in this block is your A0, A1 and CS bar, that is your chip select signal. 8255 operation is enabled or disabled by controlling the value of this CS bar. So when the value of this CS bar is 0, your operation is enabled. When the value of this CS bar is 1, your operation will be disabled. Then group A and group B control. Your group A and B gets the control signal from CPU and send that command to the individual control block. We have seen in the diagram already that your group A send the control signal to the associated blocks which are connected to group A, and to group A we have seen that port A and port C upper are connected, right? And we have also seen that in port C upper we are going to connect PC7 to PC4, and group B sends the control signal to the blocks which are connected to group B, that is your port B and port C lower, and under port C lower we are going to use PC3 to PC0, right? Then port A is a 8-bit buffered IO latch port. It can be programmed into mode 0, mode 1 and mode 2. In the later slides we are going to see what these modes are. Then port B is also 8-bit buffer, that 8-bit buffer IO latch. It can be programmed in mode 0 and mode 1 only. Port C, then come to port C. This port C is a 8-bit unlatched buffer in input and output latch. It is split into 2 parts and it can be programmed by set reset operation. So this is the pin diagram of your 8255 IC. In this IC we can see that here we have the components of port A, pins of port A, right? Then here we have port C, up to this we have port C, PC upper, and from here we have PC lower. Then this green portion PB0, PB1 and up to this pin number 25, we have port B. 8-bit data buses are connected between pin number 27 to 34. Then pin number 36 is used for VCC supply. Each IC, each circuit knows we need some supply signal. So plus 5 volt DC, plus 5 volt DC is applied so that this IC can be in working condition. Reset pin, whenever the value of reset is equal to 1, control word will be cleared. Control word will be cleared and all ports will be initialized as a input port. All the ports are ready to receive data whenever we press reset signal is equal to 1. Then we can further we can program as per our requirement. Then here we have write bar, here we have read bar, chip select signal. Whenever the value of chip select signal is 0, the IC will be in enabled mode, else it will be in disabled mode. And here we have ground, and here we have 2 address lines. Only 2 address lines are required so that we can select any one port, right, from port 1, 2 and port 1, 0, 1 and 2. So the function of these pins, data bus, these are 8-bit bidirectional buses which are connected to 8085 data buses for the transferring of data. CS bar, it is CS bar, read bar and write bar. CS bar, it is an active low signal. When it is low, the data is transferred from 8085. Read bar, whenever it is also active low signal, whenever the value is low, the operation will be started. We can read data from the input devices present at any port. Then write bar, when it is also active low signal, so whenever the value is 0, we can start the write operation. Then here we have this address lines, that is A1, A0. So when the values are 0, 0, port A will be selected. For 0, 1, port B will be selected. 1, 0, port C will be selected, and for 1, 1, control register will be selected. Reset pin, it is used to reset the device. It means that it will clear the control register, and all the ports will be initialized as a input port. Then PA0 to PA7, that is the pins of port A. It is a 8-bit bidirectional IO pins used to send data to the peripheral devices or to receive data from any peripheral device. PB0 to PB7, that is also similar to port A, pins of port A, that is they are bidirectional IO pins which can be used to transmit or to receive any data from the peripheral devices. Then this PC0 to PC7, it is also bidirectional IO pins. These lines can be divided into 2 groups, that is your lower group and higher group. So these 2 groups working separately using 4 data lines. And let me mention one more thing here, that these port C signals are used as a handshaking signals. Then the mode of operation can be classified into 2 parts. This control register can be read out. We have a 8-bit control register, and the bit present at this D7 is used to select any mode. This mode of operation, your 8255 has 2 modes of operation. One is your bit set reset mode, and the another one is IO mode. So this bit set reset mode will be selected when the D7 bit is 0. This IO mode will be selected whenever the value of D7 bit is 1. So here in bit set reset mode, the port C, it is exclusively used for port C. It is only used for port C. No other ports are going to be used in this mode. We are going to set or reset bits of port C only. So this D7 bit will always be 0 so that we can work in BSR mode. These three are don't care, we are not going to use these pins. Then B3, B1 and B0, that are connected to D3, D2 and D1. These are used to select pins from port C. Like for example, we have here 0, 0, 0, then PC0 will be selected, right? Same way, if you have 1, 1, 1 value, then PC7 will be selected. Then we have this D0 bit. D0 bit states that whenever this value is 0, this particular bit 0 will be reset, and when this value is 1, this particular bit will be set. So we can set or reset any bit by using this bit set reset mode, but only for port C. Then IO mode. IO mode, for the operation in IO mode, this D7 bit should be 1, then next bits will be changed accordingly. Mode 0, before starting these, okay, mode 0 is a simple IO input output port. In this mode, port A, B and C are used as a individually simply input and output port. We can individually program these ports as either as a input port or as a output port. Some of the features of this mode 0 are outputs are latched, inputs are buffered, they are not latched, and ports do not have any handshaking feature. They do not generate any handshaking signal. And the last thing in this mode 0 is it does not have any interrupt capability. Mode 1, in case of mode 1, this mode is known as input output with handshake. So handshake means, you know, that whenever you send some signal, the next device will send some acknowledgement signal in response to that. So in this mode, input or output is transferred by via handshaking signal. Suppose you have one computer and some printer is attached. We have this data bus, we need to transmit data, we need to print some data. So it will send some signal, that is your stop bar signal, to the printer. Printer will send back the acknowledgement signal. If the printer is ready to accept the command, if both the speeds are same, printer is ready to accept the command, it will print the command, it will print your data. Else it will send the busy signal, and microprocessor will go into wait stage and wait stage till the printer is available to print your document, right? So handshaking signal is used to transfer data between those data in those cases where the data transfer rate is not same. So for example, the computer sends the data to the printer at a very large speed as compared to your printer. Suppose your printer is working on 3 megahertz and your computer is working on 8 megahertz. So when the computer sends the data according to the printer speed, at that time only your printer can accept the data. And if your printer is not ready to accept the data, then after sending the data, computer will send another handshaking signal to tell the printer that a valid data is available on the data bus, and each port uses three lines from the port C, which will work as a handshake signal. These signals are used from port C, so that we can provide the handshaking signal to the computer. Then mode 2 is bidirectional IO data transfer. This mode allows the bidirectional data transfer over a single 8-bit data port using a handshake signal. This feature is possible only for group A. Port A is working as a 8-bit bidirectional port, and port C upper, that is PC7 to PC3, it is used for the handshaking purpose to generate the handshaking signals, and data is sent by the CPU through this port when the peripheral request is done. So in case of this mode 1, we can say that your data transfer is done once your handshaking purpose is done. So next we have this control word format. In this control word format, the input mode, in the input mode, in input IO mode, when the reset is high, all 24 pins will be in input mode, all the flip-flops are cleared and interrupt are reset. The condition is maintained even after reset goes low. This can be avoided by writing a single control word to the control register whenever required. So this is the bit set reset mode. We have seen that the value of this bit set reset mode, it should be 0 to activate the bit set reset mode, right? D0 bit should be 1 to set, and it should be 0 to set a particular port, to set or reset a particular bit. Then D3, D2, D1. So D3, D2, D1. So if the values are 0, 0, 0, PC0 will be selected, then 0, 0, 1, PC1 will be selected, 0, 1, 0, PC2 will be selected, 0, 1, 1, PC3 will be selected, 1, 0, 0, PC4 will be selected, 1, 0, 1, PC5, 1, 1, 1, 0, PC6 and 1, 1, 1, PC7 will be set or reset as per the data provided at this D0 line, right? D4, D5 and D6 we are not going to use these pins, and D7 it should be 0. D7 should be 0 so that we can work in bit set reset mode, right? So PC0 to PC7 is set reset as per the status of D0. A bit set reset word is written in each bit. For example, PC3 is set, then the control word register will be, we have to set PC3, we have to set this D0 pin should be 1 because we have to set, this is logic 3. So PC3, that is 0, 1, 1 pin, right? These three are don't care, and here we have 0. So, according to that, we will load that data to assembly language program. Then the format for this IO mode, this mode set flag should be 1, it should be activated so that it can work in IO mode. These three pins are for group A, right? We know that in case of group A we have port A, group A, it is mistakenly here, it should be port A, okay, and port C upper. So in case of if D3 bit, if it is 1, your port C upper will work as an input, if it is 0, it will work as an output. Then D4 bit, it is used for port A, port C upper, port A, right? So if bit is 1, it will work as an input, if it is 0, it will work as an output. Then we have these two pins are used as a mode selection for group A, right? Mode selection for group A, we have 2 bits. For 0, 0, mode 0 will be selected. For 0, 1, mode 1 will be selected. For 1, 0, mode 2 will be selected. As I have already told you that mode 0, 0, all three ports, port A, B and C, they will work as a individual input output pin, right? Mode 1, port A and or port B, they can work as a input output pin, and your port C will work as will provide the handshaking signal. And mode 2, in case of mode 2, your only port B will be programmed as a bidirectional, and port C lower will be used to provide the handshaking signal. Then these next 3 bits, D2, D1 and D0 are used for group B. Group B, D0 is your port C lower, this is your port C lower. So similarly, as we have seen previously, if this bit is 1, it will work as an input port, if it is 0, it will work as a output port. Then port B, it is your port B. So when it is 1, it will work as an input. When it is 0, it will work as a output. Then we are left with this mode selection bit. This is your mode selection for group B, right? So if it is 0, your mode 0 will be selected, and if it is 1, mode 1 will be selected. So lastly, we are going to see that how this interfacing is done with the 8085. So we have this IC. Right, we have this 8255 IC. Right, here we have A1, A0, okay. You have address lines. PA7 to PA0, port A, PB, PB7 to PB0, then we have PC7 to PC0, this is PB7 to PB0, okay. Here we have two address lines A1 and A0, and here we have write bar, read bar, CS bar, and what else we have? That's all, okay. Suppose we have to interface this IC with the 8085. So we know that in 8085, your A1 and A0 lines, A1 and A0 lines will be directly connected to these lines, and from then 8085 has 16 address lines, but because we are interfacing some IO devices port, we know that 8-bit data address should be used. So from A8 to A2, all these lines, all these 6 lines will be connected to the chip select signal, so that your chip select signal can be activated and your this IC can be in working condition. These pins, microprocessor will generate IO write bar. It will be connected to IO write bar, and it will generate, microprocessor will generate IO read bar signal, so that we can read devices from IO ports. And the reset out pin one more pin have reset out. Reset out of 8085 will be connected to the reset pin of your 8255 peripheral IC. Like, so this way we are going to interface any IC with the with 8255 IC, and on these ports we are going to connect your input devices like keyboard. Suppose I have connected one keyboard here and printer here, right? Printer I have connected here. So this port will be programmed as an input port. This port will be programmed as a output port, right? We are going to program that in mode, in IO mode, input output mode, right? So this way, if you are using 8086 processor, then the pins of 8086 processor will be connected to the respective pins of your 8255 IC. So this is all about the 8255 programmable peripheral interface IC, and how we are going to interface your microprocessor with this IC. Thank you so much.